Hello everyone, this is the first lesson recording for IM1, October 27th, 2020. So what are we doing today? So we are going to be tackling the unit number 3. This is the first day. That also means that if you have not been doing very well in this class, or if you have not been doing your homework and you have not been doing well on the assessment, then this might be the day that you want to turn yourself around. Okay, start focusing in class, start doing the homework. That means coming to my study hall at 2:15 this afternoon to work on the homework together, and then start doing the work. Alright, so what are we tackling today? We are going to review algebra tiles, combining like terms, and different ways of expressing area of rectangles. So I want you to answer in private chat. Okay, given this rectangle, what is the length and width of this rectangle? So hopefully you're telling me length is 5 and the width is 4. Okay, what is the area of this rectangle? Area is usually length times width. Not usually, it's always. So the area is how many unit squares fit inside the enclosure. So you are given area is a little rectangle. So if that is a unit square, then this 4 means, the length of 4 means it takes up 4 square length. Okay, so the 4 units long and 5 units long horizontally. Okay, so and the area is really talking about how many of these little unit squares fit in this red rectangle, and it turns out to be 4 times 5 because there are 4 in a column and there are 5 of those columns. So 4 times 5 is 20. So the area is 20 unit square. Okay. Alright, so I want you to tell me in private chat this time. The area of this rectangle is 12 and the length is 12. What is the width of this rectangle? If I know the area, the space inside to be 12, and the length from this to there, how long that is 12, what do you think this question mark is? Well, what number multiplied by 12 is 12? That question mark has to be 1, right? So then, okay, then let's try this problem. The area of this square is 25. So what is the width of this square? Okay, what do we know about square? Squares are quadrilateral or four-sided shape where it is 90 degrees and each of the sides are equal in length. So we know that whatever this question mark is also same as here. Okay, so the question mark times question mark is going to be 25 because length times width is 25, or the area is 25. So that question mark has to be 5. Why? Because 5 times 5 is 25. Okay, now let's go a step further. What if we're told that the area is x squared? Okay, what is the width of this square? Well, we know that something times something is x squared. So what does that question mark something gotta be? It's gotta be x times x is x squared. So question mark has to be x. Okay? Alright, so then let's get back into algebra tiles. So in previous years in your middle school, I'm assuming you've had exposure to algebra tiles, and we would have been doing this in class in IM1, but except we're doing distance learning, so we're not doing that. And algebra tiles are named after their area. Okay, so when you see these little ones, the yellow, tiny little ones, we call the onesies, and that's because they're onesies because the width is 1 and the length is 1. So 1 times 1 is 1. So the area is 1. That's why we call them onesies. And if you have this, we say the area for this rectangle is x. Why? Because the length is 1 and the width is 1 and the length is x. Okay, so this 1 is same as this one. This length of 1 is same as this length of 1. So if I put this down there, it would match up exactly. But this length of x, it's some unknown, it's a variable. Okay, so in this case, the area is x, which is the width, times 1, which is the length. So, width is 1 and length is x, so area is x. So we call this the x tile because the area is x. And then finally we call this the x squared tile. Why? Because the area, the width is x and the length is also x. So area is x times x, which is x squared. So area is x squared. So we call this the x squared tile. Alright, so then what is the total area represented by this tile? So if you see this picture, how many x's, x squares, x's, and 1's do you see? Well, I see 1, 2, 3 x squares, and I see 1, 2, 3, 4 x's, and I see 3 1's. 1 plus 1 plus 1. Okay, can I ever add x squared with x? No, I cannot because they're not like terms. Remember we talked about like terms? Okay, so all that we can do is we can add all the x squared together and you get 3 of the x squared. And we can add all the x's together. That means we have 4 of the x, so 4x. And then finally 3 1's, so we can just write it as 3. So this picture is represented as 3x squared plus 4x plus 3. Okay, and so what about this? I want you to tell me in private chat, what is the total area represented by these tiles? Okay, so for x squared, you would use x caret 2 to represent that. Okay, so what do we have? We have 4 of the x squared, that's the blue x squareds. And then we have 3 x's, 1, 2, 3, and then just 1 1z. So that means we have 4x squareds, okay, 4x squares, 4x plus x squared plus x squared plus x squared plus x squared is same as 4 times x squared, and x plus x is really same as 3 times x, and then finally x, okay. So then this is really the same as 4x squared plus 3x plus 1. Okay, remember we can omit those multiplication signs by just putting it as 4x. That is the reason when you see 4x, you should always be thinking of this as 4 times x squared. Alright, how about this one? Okay, this is a little bit different. Okay, where you see this red outline around it, it represents that it's not positive, but it's a negative. So in this case, x squared and this x squared, they're same in size, but this is a negative version of it. Okay, so negative x squared, the negative x squared, and same thing with x's and the 1's. When it has the red outline, it is the negative versions of it, of the same area. So what do you have? We have x squared, and we have a negative x squared and another negative x squared. And then we have x, but we also have another negative x, and then you have 2 1z's and 1 negative 1z. Okay, so then put that together. You see x squared minus x squared, they cancel each other out. So x squared and x minus x squared, you put them together and it just disappears. Just the same way, this x, negative x and x, put them together, they just disappear. Same thing with these two. That means you're just left with negative x2 squared minus or plus 1. And that's what we have. Alright, how about this? Okay, what is the total area here? It is negative x squared plus 3x plus 1. Okay, total area for this one. It's 2x squared minus 2x minus 3. Great, I hope you are getting the hang of it. Okay, now what if we were to add them together? Okay, so we're adding negative x squared plus 3x plus 1 and 2x squared minus 2x minus 3. So we're combining all of them together. That's what addition is. Okay, so when we add them together, what do you get? Well, this negative x squared and x squared, they cancel each other out. So all you're left with is just 1x squared. This negative x and negative x cancels out 2 of the x's here. So you're left with just 1x remaining. And then we have one of the positive 1z and negative 1z's canceling each other out. But you're still left with 2 negative 1z's. So finally, you should get x squared plus x minus 2 as your answer when you add them all together. Okay, so at this point, you are going to be working on the decimals exercises. You're going to be working on card 1 only. And card 1 is where you are grouping like terms. So when you have all these cards, you have to combine all the like terms. Okay, so I know that negative 3y and 3y's go together. So I am going to group them together. Do I have any more y's? Okay, I have 5xy. Is 5xy same as y? Well, 5y's are like yo-yos. You have negative 3 yo-yo and a yo-yo. This x and y, it's a xylophone yo-yo. It's a special type of thing. We cannot combine xylophone yo-yo with a yo-yo. So we're going to leave this as it is. Okay? What about 5x here? Are there any more x's? Yes. Okay, do we have any more x's? Yes. Alright, so what about the z's? 9z and negative 15z. And the numbers here, we have 10 and 37. Okay, so here we go. We're done. Alright, so then let's go to card number 2. Classmate grouped these 3 cards as like terms. Do you agree, disagree with your classmates? Explain. Well, when I look at this, the y's are yo-yos. Okay, but the xy is a special type of yo-yo, isn't it? Like it's a xylophone yo-yo. That's a special type. I cannot combine the xylophone yo-yos with just plain old yo-yos. So I need to keep them apart. And so I disagree because the 5xy's are different. They're not like terms with the y's. So that will be my explanation. Alright, then Ruben says the cards would simplify to be 14x. Leslie says the cards would simplify to be 2x. Who do you agree with and why? So when you have 8x, negative 5x, minus x. Okay, when you combine all of them, what do you get? Well, we're dealing with x's, so that means we can combine them. So to do that, you are just adding the coefficient. That's the number in front of the variable. So that's 8 minus 5. What's 8 minus 5? That's 3. 3 minus 1. Okay, negative with no number in front is same as negative 1. So 3 minus 1 is 2. So I would say it is 2x. So I would agree with Leslie. Okay, and my explanation is since they are like terms, you can combine the coefficient. That's the numbers in front. So 8 minus 5 minus 1 is positive 2. So you are left with 2 of the x's. So the answer is 2x. Okay, and then finally, this pick a different color for each group of like terms and circle the like terms in an expression using the same color. So I am going to use blue. And I'm going to say, okay, so 10x. Do I see any other x's? There is my 10x. There is my 6x. Okay? Alright, but I actually made a mistake here. Okay, so I don't want to just color the 6x. I want to color both 6x and the operation right before, because that whatever that operation is, the plus or minus sign belongs to the